Mr. D, and today we're going to be learning the sliding filament theory.
Smith, Ryan, what are you doing?
It's Ryan Smith.
Well, whatever. What are you doing?
I'm watching these kids dance the sliding filament theory so I can learn it.
What? That is not the sliding filament theory. That looks like an audition for the latest movie of Step Up series. Would you agree?
I would agree, but I'm learning a lot.
Let the bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the floor. Let the bodies hit the
What time is it? Mr. D, what are you doing in my bedroom?
What do you mean, what am I doing in your bedroom? We have to learn the sliding filament theory. Okay, Ryan. So, it all starts in the terminal cisternae. These blue magnets will represent the calcium ions within the terminal cisternae. So as we can see, this is one sarcomere, and this is the actin, and this is the myosin. So myosin is red, actin is black, and you can see how these two parts of the sarcomere are parallel to each other. These three magnets represent the actin binding sites in which the myosin, the red here, want to bind to. However, the tropomyosin is actually blocking these binding sites. Okay, so we can see the purple here is the troponin, and we see how closely the troponin and the tropomyosin exist upon each other. So now is when the calcium ions are released from the terminal cisternae, travel down to the binding sites, and these calcium ions cause the troponin to actually pull the tropomyosin off of the binding sites. So now the binding site is open. And the relationship between the troponin and the tropomyosin, the troponin is sort of like a hinge for the tropomyosin. So now we can see that the myosin head has been attracted to the binding site of the actin, and this movement is all taking place due to ATP1. The next thing that happens is the power stroke. We can see in this picture that this is only one of the myosin heads, but it has swiped to the left. This is what actually happens in the sarcomere during contraction, and this movement is also powered by ATP1. After the contraction has finished and the muscle has relaxed, the myosin head and tail then return back to its normal rest stage, or rest position. This is powered by ATP2. Now that the myosin heads have returned to their regular relaxed stage, the calcium ions have done their job and need to return back to the terminal cisternae. In order for the excess calcium ions to move back up toward the terminal cisternae, ATP3 is used. So ATP powers the returning of the calcium ions that have not been used in the powering of the troponin. Now, Smith, you have to remember that through the 6 steps I just explained, steps 2 to 5 always repeat until the muscle has stopped the contraction. You must remember that.
Oh, so I get it. The steps just keep repeating until all the transportation of the calcium ions are done.
Yeah, that sounds right.
Take the bass line out. Jiggle. Bounce with it. Let it bump though.
Hi, you must be Mr. D. Ryan's downstairs.
Thank you.
You're welcome.
Ryan, I knew I'd find you down here.
How did you get in my house, Mr. D?
Your mom let me in.
Why would she let you in?
Ah, that doesn't matter. I can see that you're working the pectoral majors again. Now you know exactly what's going on. Exactly.